I'm going to hand it over to Corey to run us through Daft-SQL, current progress, what's the plan moving ahead, and yeah, what folks can be excited and look out for in Daft-SQL. So Corey, take it away.
All right, so just gonna kind of do a little bit of a deep dive into like how we added support for SQL to Daft, and then kind of talk about, go through a quick little live demo, and then finally talk about some of the stuff that we have planned for the future. So I have this notebook I'm gonna share. It's pretty quick. We're gonna just kind of go through it and talk about the different components of the SQL engine that we added. All right, can everybody see my screen?
It's starting. Yes, we see it.
Okay, so I'm gonna kind of go over the different components of the SQL engine and which one of those are new and which one of those are kind of part of the existing system and how we leverage the existing components from the data frame engine. So first, when we're doing the SQL planning, we first need to figure out, need to like tokenize the query itself, break that down into various tokens. There's a lot of like, I'm sure everybody here has heard of the term tokenization. You know, it's really popular with machine learning, and they'll do a lot more advanced stuff. But for SQL, it's pretty straightforward. Like you just have, you know, a bunch of keywords and a few other types like a word and punctuations, very simple tokenization process. There's a bunch of different ways of doing it. The most simple would be just like doing like a regex. There's other like parser libraries like non or past or a whole bunch of different tools for tokenization. We're using the SQL parser crate, which handles both tokenization and the next step of parsing. But I think it's kind of important to know the full process of what's actually happening with these queries. So when the tokenization happens, you know, we get a query like this, and it's going to get broken down into various tokens, like select keyword, then the word name, comma, and so on. So that's kind of the process of the tokenization, breaking down the query based off of a set of like grammatical rules, like there's no syntactic analysis or semantic analysis happening. It's purely just based off of the like lexicon of the grammar.
And so
And
it's Corey,
then
I guess, even for example, whether this word means like a column or a table, like that doesn't even come into play here.
no, that doesn't come into play at all. It's purely just breaking it down based off of like a grammar. The parser is actually where it applies like the syntactic rules, like, you know, this is a table, this is a select statement, this is syntactical things from the language. And, you know, you can apply this to any language, like, you know, if you're writing in Python, this is a function which has arguments which have types on them and so on. Same thing applies with SQL. We break that down into a syntax tree that represents the entire structure in a hierarchical form. Like I said, it's up to the parser to check the syntax, like a select followed by a list of expressions, a from statement followed by a table name, and so on. What it doesn't do is perform semantic analysis, like does this table exist? Are these expressions in the select statement valid? It's not doing anything at that stage. It's just, is this syntactically correct? And that's kind of the job of the parser, is taking the tokens and converting that into syntactically valid structure. For implementation details, it's a top-down recursive descent parser is a pretty common approach. There's a couple other different parsers like bottom-up and various different approaches for parsing. But the top-down one is pretty common approach when dealing with like programming languages. And what this same query up here would look like after being converted into like a syntax tree would be something that looks kind of like this. It's a select statement, it has a projection, it has a from, and then it has a filter. And if this was like nested select statements, you could easily see how this query would get pretty nested and kind of resemble more of like a tree syntax. So now that we have the syntax tree, we can actually start plugging that into our existing system, which is our query planner, also known as our logical plan. And the logical plan is, or the process of converting the syntax tree to the logical plan, that's where we start doing semantic analysis, like, is this table valid? Are these expressions, do they exist? Things of that nature, like actually validating, schemas and all that other stuff. And, ensuring the tables referenced in the query exist, columns referenced exist, checking that the functions are being used on the right types and so on. At this stage, it's putting this syntax tree into the same data structure that we use for the data frames, like when you're creating the data frame through the Python API, what it's doing is building up this logical plan. So it's kind of the same level of abstraction. The data frame API and this SQL AST are kind of two different front ends. You can kind of think of it, one of them being data frame, the other one being SQL. They're both different front ends for the query planner and the execution engine. And then kind of moving into some more of the existing stuff as we have, query optimizer. This uses the same engine as the data frame one as well. Here's a quick example of, some of the optimizations we're doing is like projection pruning, which is going to remove columns that aren't used in the final query. And, here there's a like select star in the inner query, but not all of those are going to be used. So we can prove that only ID and name are used in the final query. So why bother querying all of them? That's just an example of one of the optimizations. Interestingly, there's a lot of optimizations that we've been building out, such as cross-join eliminations and expression. There's some of the upcoming ones like expression optimizations that are much more prevalent when you're writing SQL, because there's so many different ways of writing SQL queries. You really need a strong optimizer to plan that and get rid of, all these inefficient queries. With the data frame API, it's a little bit more restrictive, and there's not quite as many ways to write inefficient queries. So a big part of the SQL effort is also going to be expanding these optimization rules, which will also improve the data frame engine as well. So it's kind of like a win-win. And finally, there's the execution. That's kind of like the swordfish stuff. I think there was a presentation on that pretty recently, so I don't want to take up too much time getting into all that. But I did want to do a quick little live demo. we're going to try to find the city with the most haunted places. So I have this CSV I pulled off that's just got a list of haunted places and
Is this a Halloween theme? Is
yes,
it this for Halloween?
yes, Halloween themed there. And just contains some basic information about city, country, description, location, and then coordinates as well. So what we're interested in is just finding out what the city with the most reported haunted places from this data set are. So we can write a simple SQL query. We're just gonna do like a group by city, get the count off of that, and then we're gonna get the top 10. So pretty simple, straightforward SQL query. And according to this, Los Angeles has the most reports. So then just for fun, we're gonna take a look at the descriptions for that. So let's see what else is maybe. Let's also grab the location.
Corey, I see you're already planning your next trip to LA.
So yeah, now we can see a bunch of these different haunted places and kind of what their descriptions are. And yeah, that's just my really quick little demo. We have a lot more planned for what we're going to support. We're very actively working on this right now. Our SQL support is still pretty limited. It should work for most basic queries, but we're really focusing on expanding that out to support a lot more complex queries and like full end-to-end SQL workflows. Right now we have support for basic queries, CTEs, joins, group bys, functions, a few other basic operations. Some of the things that are on our roadmap are things like subqueries, window functions, doing write operations, like you could do like a copy to and sync that out to a file path, eventually supporting user-defined functions, more data source integrations. Right now, we only have support for Parquet and Delta, I believe, but we want to be able to have more support for CSV, JSON, all the things that we can do through the data frame API, and then more catalog and table integrations, like integrating with Delta Lake and all those other different table format systems. More long-term on the roadmap, we would also want to support like DDL and DML operations, create, insert, update, deletes. They're pretty far out right now, but it is something we've been thinking about and definitely want to add support at some time. And then also there's Jupyter SQL. We've had some people request support for that. So, you could just do the like SQL magic and run Daft-SQL that way. Plenty of other stuff on the roadmap, but these are just kind of the ones that I thought were worth highlighting. And yeah, that's probably a lot of information to take in, but any questions anybody has?
I had a question about logical plans. I believe like Spark, for example, has a concept of an unresolved logical plan where it doesn't yet resolve it against like tables and types and all that. Like, do you think that is the right way to do things? Because right now our logical plan at creation time, we always check the types and everything, right? Which I wonder if that could be restrictive for certain scenarios when maybe we don't have the information up front, but we might want to save a view or something like that. Like, do you have any thoughts there, Corey?
Um, I mean, I think that something like that could be beneficial, but it's also like a lot of, maybe it's something we don't need at this time. But as we evolve more, it might make more sense to have like a more of like a purely daft AST representation that doesn't do any type of validations, like you said, a unresolved plan might be able to open up some more possibilities for like optimizations at that stage as well.
Yeah, because I feel like one difference between SQL and say data frame APIs is that with the data frame, the user is kind of incrementally calling things in the
Mm,
Python interpreter. And so we can always like, I guess, run incremental validations and type checks and all that. But with SQL, it's just you plug in a SQL string and hope for the best, right? So
yeah.
the user experience there is a little bit different. Yeah, we don't have as much control almost of like every step of the way. So
Mhm.
yeah, that's gonna be an
I mean,
interesting.
unless you get into like, creating CTs and like views and
Exactly.
materialized views and all that kind of stuff, which I think, eventually we could support, but it's definitely pretty far down the road for us right now.
Yeah, or even like simple things like we don't have as much control around, say, the auto completion story today, unless we have our own UI or something similar, right?
Mhm.
Just like on a user experience level of using SQL, like, hey, like what is string contains? Is it string underscore contains? Is it just contains? That sort of stuff. It's a bit harder to control the experience around if it's not in Python.
I think some SQL implementations will look for a catalog. Like I know if you implement like the Postgres protocol, it does have auto completing by looking through like the PG catalog tables. And I think, DuckDB does something similar by having like these embedded catalog tables of what their function definitions and all that stuff are. And, as we build up our support, like something like that would definitely be beneficial to have. So you got those like docs built into the system. Like you don't need to go to a doc page. You can just, select from a table and get all the autocomplete features and all that kind of stuff built in.
I had a question about the parsing. So I was just wondering, how are we doing the SQL parsing? If you, I think you had this earlier on in your presentation, the whole like tokenization part, and then actually building up the syntax tree. We're doing this like
So
ourselves, or are
this
we using
is
like a
handled
crate and
by
like
the
what sort of like testing does that crate have, or etc. The whole story around that.
So this is all handled by the SQL parser crate. It's managed by the Apache Data Fusion project. It's pretty widely used in a lot of data frame libraries. Data Fusion uses it pretty extensively, and there's dozens of projects that use Data Fusion. And I've worked with it. I've made a few contributions to the project as
Mm.
well. They got pretty extensive test suite, and it's a pretty robust library for tokenization and parsing of SQL.
Very cool, very cool. Thanks.
Cool. Any more questions? Otherwise, I guess, Chan, I'll hand it over back to you. We can conclude maybe.
Okay, awesome. If there are no more questions, I think that is all we have for the contributor sync today. The next one will not be on the last Thursday of November because that's Thanksgiving. So I think we're going to plan for the week before. It should be November 21st, Thursday. And then I think that's all. Thank you guys. Thank you, Corey, for presenting. That was awesome. Thank you guys for tuning in. And I'll be posting this on YouTube in about a week or so you guys can watch it back.
Thanks.
Okay,
Thanks, Corey.
awesome. Thank you,
Yeah.
everybody. Bye.